Hey everyone, Jason here again. Just want to make a quick video again on the chi-square goodness of fit test. And in this example, I just wanted to highlight the option for your null hypotheses that states there is no difference from a known population. So as I said in the previous video where we had chosen the equal proportions option, whether you choose option 1 or option 2 will affect your expected frequency distribution. And so in this case, no difference from a known population. Basically, I'm taking the number of people I have in my sample, that's 60, and I'm looking at the population proportions, and then I'm determining what I would expect of my sample in terms of the frequency distribution for each category. So let's just say this is what we expected: 10 people in A, 18 in B, 9 in C, 23 in D, right? And this is what we observed. And again, same thing, we're just trying to see, is this distribution different from this distribution? And is it significant? And so everything stays the same except for our actual chi-square value. So our degrees of freedom are the same, there's still 3. Still have 60 people. Our critical chi-square is the same because we still have the same degrees of freedom. And our actual chi-square value is different now because we have different expected frequencies. So I wrote it out here. And if you solve for this, what you're going to get is 28.35. Okay, and you can go ahead and try that out if you're unsure about the math. So that's our chi-square value, and it's clearly bigger than our critical chi-square value. So we know this is significant, and this actually comes from an alpha level of 0.05. Now let's just jump into our SPSS. Okay, exact same data that we had in the previous example. 4 categories, A, B, C, and D. All right, and now look how they're ordered. Right, 1, 2, 3, 4. A, B, C, D. Keep it simple, right? It's in order, and the order will matter because I'm going to go to Analyze. Where's my non-parametric? Legacy dialogues, chi-square. Okay, same thing. Throw in the variable list box. And now instead of all categories equal, right? That was our first option for our null hypothesis. We're going to specify the distribution. Okay, and now this, when you're adding the numbers in, it's in the numerical order of the variable categories. So A, B, C, D, that's the order. So A comes first, and let's just check out what we expected. 10 for A, 18, 9, and 23. 10, 18, 9, 23. Okay, so that's pretty simple, right? 10, add. 18, add. 9, add. 23, add. Now, the order I put them in, okay, it knows this is A, B, C, and D, and that's because that's how I have my variable category ordered. 1, 2, 3, 4, A, B, C, D. So I'm going to hit OK because that's all we have to do, and everything is more or less the same as it was previously, except now we have a different expected column, right, with our specified values. Our chi-square value is 28.35, which is exactly what we calculated here. And the degrees of freedom is 3 as well, and our significance is 0.000, so it's less than 0.001. Very significant. So that's how you do the chi-square value when you have a null hypothesis that states there is no difference from a known population. If you have any questions, please feel free to message me. If not, stay tuned for my next video in this video series. Cheers.